The morning of May 24, 1943, broke cold and gray across the North Atlantic, the kind of morning where the line between ocean and sky dissolved into a single colorless void that stretched to every horizon. Convoy ONS-5 had been under sustained attack for 6 days, harried by a wolf pack of 41 German U-boats that represented one of the largest submarine concentrations ever assembled against a single convoy. The escorts had been fighting a running battle that seemed to confirm Germany's most optimistic projections about the tonnage war. Merchant ships were going down faster than Allied shipyards could replace them. The mathematics of attrition appeared to favor the Kriegsmarine. Admiral Karl Donitz had calculated that sinking 700,000 tons of Allied shipping per month would strangle Britain's supply lines and force a negotiated settlement before American industrial capacity could reach full mobilization. In the first 4 months of 1943, his U-boats had exceeded that target, sending more than 3 million tons of Allied shipping to the bottom of the Atlantic. The strategic calculus seemed clear. Germany was winning the Battle of the Atlantic through a campaign of systematic economic strangulation that required no dramatic victories, only the patient accumulation of sunken tonnages until the mathematical reality became unbearable for the Allied war effort. What Donitz did not know, could not have known as he reviewed the attack reports from ONS-5 in his headquarters at the Hotel am Steinplatz in Berlin, was that his entire operational framework was about to collapse under the weight of technological innovations and industrial capacities that German naval intelligence had catastrophically underestimated. The tactical situation around ONS-5 appeared to validate every assumption embedded in German submarine doctrine. The convoy consisted of 42 merchant ships carrying food, fuel, ammunition, and raw materials essential to sustaining Britain's war economy. It was defended by a close escort group of 2 destroyers, 4 corvettes, and a trawler, precisely the kind of defensive screen that German tactics had been designed to overwhelm through coordinated night surface attacks. The U-boats had made contact on May 4th and had been shadowing the convoy ever since, waiting for optimal weather conditions to launch a mass assault. When the attack finally came on the night of May 5th, it demonstrated the terrifying effectiveness of Wolfpack tactics refined through 3 years of Atlantic operations. 5 merchant ships went down in the first hour. 3 more sank before dawn. The escorts fired star shells that illuminated nothing but empty ocean. They dropped depth charges that detonated harmlessly in the wake of submarines that had already submerged and relocated. The convoy commodore's reports back to Western Approaches Command in Liverpool described a situation approaching disaster, the kind of engagement where escorts were simply outnumbered and outmaneuvered by an enemy operating with tactical initiative and operational flexibility. But something happened during the second night of attacks that did not fit the established pattern of convoy battles. U-boats that had been transmitting attack reports suddenly went silent. Submarines that should have been pressing home their advantage broke off contact and began evasive maneuvers. By the morning of May 6th, the Wolfpack had lost 3 boats with all hands, and the surviving commanders were reporting conditions that made continued surface operations suicidal. The weapon system that broke the back of the ONS-5 Wolfpack was not a single invention, but a convergence of technologies that represented the Allied solution to submarine warfare distilled into operational reality. The escorts attacking those U-boats were equipped with Type 271 centimetric radar that could detect a surfaced submarine's conning tower at 6,000 yards in complete darkness and moderate sea states. This was not the meter wave radar that U-boats had learned to detect and evade in 1942. This was 10-centimeter wavelength radar operating at frequencies the Germans had dismissed as impractical for maritime use because they believed the technical challenges of generating sufficient power at those wavelengths could not be solved aboard small escort vessels. The British had solved it through the cavity magnetron, a device that generated microwave frequency radio waves with power outputs sufficient for tactical detection ranges. The magnetron itself was a technical achievement that German scientists considered theoretically possible, but practically unattainable given the precision manufacturing tolerances required. British physics laboratories at the University of Birmingham had developed the initial prototype. The General Electric Company in Britain had refined it for mass production. American factories, particularly the Raytheon Manufacturing Company in Waltham, Massachusetts, had scaled production to rates that put centimetric radar sets aboard hundreds of escort vessels by early 1943. This was applied physics converted into industrial output and then translated into tactical advantage at a pace that rendered German countermeasures obsolete before they could be widely deployed. The escorts hunting U-boats around ONS-5 were also equipped with improved high-frequency direction-finding equipment, known universally as Huff-Duff, that could triangulate the position of any U-boat transmitting on high-frequency radio bands. German submarine doctrine required frequent radio communication to coordinate wolfpack attacks. U-boat commanders reported contact with convoys to Dunitz's headquarters. They transmitted weather observations. They coordinated tactical movements with other boats in the pack. Each transmission created an electronic signature that Huff-Duff receivers could detect and locate with accuracy measured in nautical miles rather than the tens or hundreds of miles possible with earlier direction-finding technology. The Germans knew the Allies possessed direction-finding capability, but they had calculated that the time required to obtain a fix was long enough that submarines could transmit their essential reports and submerge before escorts could respond. That calculation had been accurate in 1941 and early 1942. By mid-1943, it was lethally wrong. The new Huff-Duff sets could obtain a bearing in seconds and triangulate a position using multiple receivers in under a minute. A U-boat that surfaced to send a contact report found itself under attack by escorts that had been vectored to its position before the transmission ended. The delayed realization came to individual U-boat commanders in moments of tactical confusion that accumulated into strategic comprehension. Kapitänleutnant Herbert Werner, commanding U-415 as part of the ONS-5 attack, described surfacing to make a night approach and immediately being illuminated by searchlight from an escort that should not have known his position. He crash-dived and rigged for depth charging, listening through the hull as explosives detonated close enough to spring hull plates and shatter light fixtures. When he surfaced 3 hours later, cautiously scanning for threats through his attack periscope, another escort was waiting less than 1,000 meters away, already turning to ram. Werner survived that encounter through emergency maneuvers and the sacrifice of his remaining torpedo spread to force the escort to break off, but his after-action report described tactical conditions that made successful attacks impossible. The escorts could see in the dark. They knew where U-boats were even when those boats were running silent. They responded to threats faster than German doctrine said surface ships could respond. The fundamental assumptions underlying wolfpack tactics, assumptions validated by hundreds of successful convoy attacks, no longer corresponded to battlefield reality. The technical specifications of the Allied anti-submarine arsenal in May 1943 reveal a systematic approach to solving submarine warfare that German naval planning had failed to anticipate. Beyond radar and Huff-Duff, the escorts around ONS-5 carried an improved version of the Hedgehog anti-submarine mortar that fired 24 contact-fused projectiles in an oval pattern ahead of the attacking ship. Unlike depth charges that detonated at preset depths and allowed U-boats to escape if the escort's depth estimates were inaccurate, Hedgehog projectiles only exploded on direct contact with the submarine's hull. This meant that every explosion confirmed a hit, and the absence of explosions told the escort commander immediately that his attack had missed and he needed to reposition for another run. The weapon eliminated the guesswork that had characterized depth charge attacks and dramatically increased the kill probability of each engagement. A single Hedgehog salvo that straddled a submerged U-boat could penetrate the pressure hull in multiple locations simultaneously, flooding compartments faster than damage control teams could respond, and sending the boat to the bottom in seconds rather than the minutes that might allow crew evacuation. The escorts also benefited from improved sonar sets that could maintain contact with submerged submarines at greater ranges and with better resolution than the ASDIC systems used in earlier convoy battles. The Type 147B sonar could track a submerged U-boat at 2,500 yards under favorable conditions and could differentiate between a submarine contact and the thermal layers, wreckage, and biological returns that had previously created false targets. This extended tracking range gave escort commanders time to maneuver into optimal attack positions and to coordinate multiple ships in barrier tactics that forced U-boats into increasingly constrained operational spaces. A submarine that dove to escape one escort often surfaced directly into the sonar coverage of another ship positioned precisely to intercept based on predicted evasion routes. The Germans had trained their commanders to execute standard evasion patterns that maximized the probability of escaping a single attacker. Those patterns became death traps when facing multiple coordinated escorts equipped with sensors that provided continuous tracking through the evasion sequence. The industrial mathematics supporting this technological superiority represented a strategic investment that dwarfed German submarine production in every measurable category. By May 1943, Allied shipyards were launching escort vessels at a rate of more than 40 ships per month. This figure includes destroyers, destroyer escorts, frigates, corvettes, and sloops across British, Canadian, and American construction programs. The destroyers alone represented an extraordinary manufacturing achievement. A Fletcher-class destroyer required approximately 21 months from keel laying to commissioning in 1941. By 1943, American yards had reduced that timeline to 14 months through improved welding techniques, prefabricated hull sections, and assembly processes borrowed directly from automotive manufacturing. The Bath Iron Works in Maine, the Federal Shipbuilding and Dry Dock Company in New Jersey, and the Consolidated Steel Corporation in California were producing warships with the systematic efficiency of factories stamping out consumer goods, and behind those primary yards stood dozens of smaller facilities building corvettes and frigates that brought total escort production to levels that simply overwhelmed German U-boat construction. Germany commissioned approximately 20 U-boats per month during the first half of 1943, a production rate that represented the maximum output achievable given steel allocations, skilled labor availability, and the competing demands of tank and aircraft production. Each Type VIIC U-boat required approximately 30,000 man-hours to construct and consumed 250 tons of specialized steel that had to meet exacting specifications for pressure hull integrity at depth. The construction process was concentrated in a handful of yards, primarily Deutsche Werft in Kiel, Germania Werft in Kiel, and Hoaltz Werft in Hamburg, facilities that were increasingly vulnerable to Royal Air Force bombing as Bomber Command shifted resources toward strategic interdiction of German war production. A successful raid on the U-boat pens at Hamburg in July 1943 would destroy or damage more than a dozen boats under construction, effectively eliminating an entire month's production in a single night. The Allies were building escorts faster than Germany could build submarines, and they were doing it with industrial redundancy that made individual facility losses tactically inconvenient rather than strategically catastrophic. The logistical lungs supporting Allied anti-submarine operations extended far beyond shipbuilding into every aspect of the maritime supply chain. The convoy system required not just escorts, but also the infrastructure to maintain them, fuel them, arm them, and crew them across operational areas spanning the entire Atlantic basin. The Royal Navy maintained repair facilities in Liverpool, Londonderry, Greenock, and a dozen smaller ports around the British Isles. The Canadian Navy operated bases in Halifax, St. John's, and Sydney that could handle everything from routine maintenance to major battle damage repair. The United States Navy established forward support facilities in Iceland, Argentia, and Newfoundland, and later in the Azores that brought repair capacity within a few days' sailing of the mid-Atlantic Gap where U-boats concentrated their attacks. This distributed infrastructure meant that an escort damaged in combat could reach a repair facility, complete necessary work, and return to operational status within 2 weeks, rather than the month or more required if that ship had to return to a major shipyard. The Germans had no equivalent capacity for forward U-boat support. A submarine that suffered machinery damage or hull cracking from depth charge near misses had to return to bases in occupied France or Germany for repair, a transit that could take 2 weeks in each direction and remove that boat from operational service for a month or more. The kinetic reality of the May battles around ONS-5 reflected this accumulation of Allied advantages in ways that individual U-boat commanders experienced as inexplicable tactical failures. On the night of May 5th, U-638 surfaced to make a night approach and was immediately bracketed by star shells from an escort that opened fire with 4-inch guns at a range of 3,000 yards. The U-boat crash-dived and went deep, running silent while the escort passed overhead, dropping a pattern of depth charges that detonated close enough to jam the boat's dive planes and rupture fuel tanks. U-638 limped back to base with a fractured pressure hull and never returned to operational service. U-531 was detected by radar while still submerged at periscope depth, a tactical impossibility according to German understanding of radar capabilities, and was sunk by hedgehog attack before the crew could react to the contact. U-192 transmitted a contact report and found itself under attack by 2 escorts within 3 minutes, forcing an emergency dive that was interrupted by hedgehog impacts that flooded the control room and sent the boat to the bottom with all hands. The pattern repeated across the entire Wolfpack. U-boats that should have had tactical initiative found themselves reacting defensively to threats they could not predict or counter. The mathematics of attrition that had favored Germany in the first quarter of 1943 reversed catastrophically. ONS-5 lost 13 merchant ships, a painful loss by any measure, but the attacking Wolfpack lost 7 U-boats destroyed and 11 more damaged severely enough to require return to base for repairs that would keep them out of action for months. The psychological impact on surviving U-boat crews manifested as a collapse of confidence that rippled through the entire submarine force. Werner's patrol report described conditions that made continued operations untenable. Other commanders filed similar assessments. The escorts could detect submarines under circumstances where detection should have been impossible. They could attack with weapons that required direct hits and seemed to achieve those hits with disturbing frequency. They coordinated in ways that suggested real-time tactical communication rather than the delayed and imperfect coordination German intelligence had attributed to Allied escort groups. The cumulative effect was a growing conviction among U-boat crews that they were being sent into combat against an enemy who possessed fundamental technical advantages that no amount of tactical skill could overcome. This was a profound shift from the operational culture that had sustained the U-boat force through the difficult years of 1940 and 1941, when they were sinking ships faster than Britain could replace them. That earlier period had been characterized by a sense of tactical superiority, of hunting merchant convoys that were poorly defended and escorts that were inadequately equipped. By May 1943, the U-boat crews were the ones being hunted, and the predator-prey relationship had reversed in ways that made every patrol a calculated gamble with survival. Dönitz recognized the strategic implications of the May losses with a clarity that forced decisions no naval commander wants to make. On May 24th, the same morning when the remnants of the ONS-5 Wolfpack were limping back to bases in France, he issued orders temporarily withdrawing U-boats from the North Atlantic convoy routes. The directive was phrased as a tactical repositioning to allow for re-evaluation of convoy defense capabilities and integration of new countermeasures, but the operational reality was unmistakable. The Kriegsmarine had lost the Battle of the Atlantic. The tonnage war that was supposed to strangle Britain into submission had instead become a war of attrition that Germany could not sustain. In May 1943 alone, 41 U-boats were lost, representing nearly a quarter of the operational submarine fleet.
The experienced crews who had survived the early years of the war, the veterans who understood Atlantic weather patterns and convoy tactics, and the thousand small skills that kept men alive in pressure halls under the ocean were being killed faster than training programs could replace them. New crews arriving at operational flotillas had perhaps 4 months of training compared to the year or more that pre-war crews had received.
The technological countermeasures that Germany attempted to deploy in response to Allied anti-submarine capabilities arrived too late and in insufficient quantities to alter the strategic trajectory. The Medox radar warning receiver that could detect meter-wave radar emissions became standard equipment on U-boats by late 1942, but it was useless against centimetric radar and actually made boats more vulnerable by requiring an external antenna that increased radar cross-section. The acoustic torpedo, designated T5 Zaunkönig, entered service in September 1943 with the capability to home on the propeller noise of escort vessels, but Allied countermeasures in the form of towed noisemakers rendered the weapon largely ineffective within months of deployment. The Schnorkel breathing apparatus that allowed U-boats to run diesel engines while submerged at periscope depth provided some protection against radar detection, but it reduced maximum speed to 6 knots and created a distinctive wake that trained lookouts could spot under good visibility conditions. Each German innovation was met by an Allied counter-innovation deployed faster and in greater numbers than German intelligence believed possible. The industrial capacity supporting Allied technological superiority extended into areas that never appeared in dramatic after-action reports but fundamentally shaped operational outcomes. The Allies produced sufficient high-octane aviation fuel to maintain continuous air patrols over convoy routes using long-range aircraft that could remain on station for hours searching for surfaced U-boats. The Very Long-Range Liberator bombers, operating from bases in Iceland and Newfoundland, closed the mid-Atlantic air gap that had previously provided U-boats with a sanctuary beyond the range of land-based aircraft. These patrols required staggering quantities of aviation gasoline, more than 1,000 gallons per aircraft per mission, sustained across hundreds of daily sorties. The logistics of delivering that fuel to remote airfields in Iceland and northern Canada, maintaining the aircraft, training the crews, and coordinating their operations with surface escorts represented an organizational achievement that dwarfed anything Germany could replicate. The Luftwaffe had neither the long-range aircraft, nor the fuel reserves, nor the operational infrastructure to provide comparable air cover for U-boats, and the absence of that capability left German submarines vulnerable during every moment they spent on the surface. The human cost of the Atlantic battle resonates through the casualty statistics with a clarity that transcends strategic analysis. Of the approximately 40,000 men who served in German U-boats during the war, 30,000 died. This represents a loss rate of 75%, higher than any other branch of service in any combatant nation during the Second World War. The men who crewed those boats were not fanatics or criminals. The morning of May 24, 1943, broke cold and gray across the North Atlantic. The kind of morning where the line between ocean and sky dissolved into a single colorless void that stretched to every horizon. Convoy ONS-5 had been under sustained attack for 6 days, harried by a wolf pack of 41 German U-boats that represented one of the largest submarine concentrations ever assembled against a single convoy. The escorts had been fighting a running battle that seemed to confirm Germany's most optimistic projections about the tonnage war. Merchant ships were going down faster than Allied shipyards could replace them. The mathematics of attrition appeared to favor the Kriegsmarine. Admiral Karl Dönitz had calculated that sinking 700,000 tons of Allied shipping per month would strangle Britain's supply lines and force a negotiated settlement before American industrial capacity could reach full mobilization. In the first 4 months of 1943, his U-boats had exceeded that target, sending more than 3 million tons of Allied shipping to the bottom of the Atlantic. The strategic calculus seemed clear. Germany was winning the Battle of the Atlantic through a campaign of systematic economic strangulation that required no dramatic victories, only the patient accumulation of sunken tonnages until the mathematical reality became unbearable for the Allied war effort. What Dönitz did not know, could not have known as he reviewed the attack reports from ONS-5 in his headquarters at the Hotel am Steinplatz in Berlin, was that his entire operational framework was about to collapse under the weight of technological innovations and industrial capacities that German naval intelligence had catastrophically underestimated. The tactical situation around ONS-5 appeared to validate every assumption embedded in German submarine doctrine. The convoy consisted of 42 merchant ships carrying food, fuel, ammunition, and raw materials essential to sustaining Britain's war economy. It was defended by a close escort group of 2 destroyers, 4 corvettes, and a trawler, precisely the kind of defensive screen that German tactics had been designed to overwhelm through coordinated night surface attacks. The U-boats had made contact on May 4th and had been shadowing the convoy ever since, waiting for optimal weather conditions to launch a mass assault. When the attack finally came on the night of May 5th, it demonstrated the terrifying effectiveness of Wolfpack tactics refined through 3 years of Atlantic operations. 5 merchant ships went down in the first hour. 3 more sank before dawn. The escorts fired star shells that illuminated nothing but empty ocean. They dropped depth charges that detonated harmlessly in the wake of submarines that had already submerged and relocated. The convoy commodore's reports back to Western Approaches Command in Liverpool described a situation approaching disaster, the kind of engagement where escorts were simply outnumbered and outmaneuvered by an enemy operating with tactical initiative and operational flexibility. They were submariners who believed in their mission and their equipment and the tactical doctrine that was supposed to keep them alive. They went to sea in pressure hulls that offered no possibility of survival if depth charges breached the hull at depth. They understood the risks in abstract terms, but the delayed realization that they were fighting against industrial and technological superiority that made their deaths mathematically inevitable came too late for most of them. The escorts that hunted them were crewed by men who understood the stakes just as clearly. Allied merchant sailors died at rates approaching 25% in the worst periods of the Atlantic battle. The difference was not in courage or commitment, but in the industrial systems supporting each side's combat operations. The legacy of the May 1943 turning point in the Atlantic extends beyond the immediate tactical lessons about radar and sonar into the fundamental nature of industrial warfare. The United States entered the Second World War with an economy that represented approximately 40% of global industrial output. That productive capacity was mobilized with an efficiency that confounded enemy planning assumptions. The same factories that had built automobiles retooled to build tanks and aircraft and engines and instruments. The same workforce that had endured the Depression found employment in war industries at wages that created a broad middle class. The same logistical networks that had distributed consumer goods across a continental nation were adapted to move military supplies across 2 oceans simultaneously. This was not simply a matter of having more resources than the enemy. It was a systematic application of industrial management techniques to the problem of warfare, treating military production as an engineering challenge that could be solved through the same methods that had revolutionized civilian manufacturing in the previous decades. The Battle of the Atlantic was won in the factories of Detroit and Pittsburgh and the shipyards of Portland and San Francisco as much as it was won in the cold waters of the North Atlantic. Every Liberty ship that delivered cargo to Britain represented thousands of individual manufacturing operations coordinated across hundreds of supplier companies. Every escort vessel carried radar sets and sonar equipment and weapon systems that required precision manufacturing and quality control processes that German industry could not match under wartime conditions.
The Allied victory was not inevitable, but it was made probable by industrial decisions that prioritized scalability and reliability over individual technical excellence. The U-boat was arguably a better submarine than anything the Allies built, but that technical superiority became irrelevant when faced with escorts that could detect submarines under any conditions and weapons that could kill them with increasing efficiency. The strategic calculus favored the side that could build adequate equipment in overwhelming quantities over the side that could build excellent equipment in limited numbers, and that calculus expressed itself in the mounting losses that forced Donitz to withdraw from the Atlantic in May 1943. The war continued for 2 more years, but the outcome in the Atlantic was determined in those spring months when Allied industrial capacity finally overwhelmed German tactical excellence and made the oceans safe for the convoys that would sustain the liberation of Europe.